Good evening, all of you. Are you audible, guys? Okay, right, guys. So in the last session, we started normalization and so normalization definition and the purpose of normalization. And without normalization problems, we discussed in the last class. Okay, na? Right. And later, finally, these normalizations, again, we have some techniques are there. The total 6 techniques we have it here. Okay, so the types of normalizations here. So first, second, third, BCNF, and fourth normal form and fifth normal form. Okay, right. So now these are normalizations forms we can call. Okay, and when come to the first normal form, when your table is called as a first normal form, and when the table is in the first normalization form means so every technique is having some specific reason. Okay, let you see one by one. So first normal form, simply we can say, guys, here for a table to be in the first normal form, it should follow the following 4 rules. It should be follow the following 4 rules. Okay, now? So it should be follow the following 4 rules. Okay. So first rule is what now here? Carefully observe. Each column should contain atomic value. That means atomic is nothing but single value. So the statements carefully read and understand, guys, here. Okay. So each column, so in your table, we are creating number of columns, right? So in each column, okay, should contain a single or atomic value. Atomic is nothing but one value. Okay, that should be there, first thing. That should be there, first thing. Okay, now, right. So now, for example, can you see column name 1, first column, and this is second column. But in first column, can you see each and every row value is a single value is there, A, B, and C. Okay, now A, B, and C. Okay, so there is nothing problem. But column number 2, if you want to see, so we have a X comma Y and W comma Z. So, but as a first rule of first normal form, what it was telling guys here, atomic value should contain in each column. Atomic value should contain each column. So this column is, you can see A, B, C. So nothing problem. This is completely satisfied. This is completely satisfied. But when I come to second column, in second column, if you want to see, so this row is satisfied, single column, but this is not satisfied. X comma Y, W comma X. So these are not satisfied. Okay, now? Right. So, but what it was telling the first rule, each column should contain atomic value. That means each column should contain single values only supported. But multiple values, once it was there in the column, then it was showing not satisfied the rule. Okay, now? This is first rule. Second rule is what now? A column should contain values that are same data type, guys. So that means your column is which data type your column. So that related data only we can save and we can store. But other, that means the interchange of data type data cannot accessible. For example, you can see in the name column, this is name column, and this is date of birth column. Generally, name column is a varchar. So this is satisfied and this is also satisfied. So these two values are satisfied. But in this name column, if you sending some date expression, this is not satisfied. That means data type is not the same, different data type data. Here also date of birth. This is satisfied. This is satisfied. But Miller is a character not satisfied. So that means what you understand, guys, here. So that means what you understand, guys, here. Okay, now. So a column should contain values that was same data type values. Suppose your column is integer, integer values only store. Varchar, string only store. Data, date only store. But any intermix, if it is happening, that should not be allowed. That should not be allowed. This is a second rule. Okay, now? Right. And the third one is called as a, third rule is what now? All the columns in a table should have a unique names. That means every column, so that means how many columns are you created in your table, but every column name should be unique. But duplicate column names are duplicate column names are not accepted. So here, for example, your table will be having like these are the columns, right? So these are the columns. But in this is date of birth column and name column. But unfortunately, these both columns are same name is there. Yes or no? So same column name is there, name and name. So this is should not be there because every column name should be unique name. Unique means different name, but it never accepted the duplicate column names. It never accepted duplicate column names. So this is also one rule should be remembered. Finally, the fourth rule is what it was telling guys here. Fourth rule, the order. Okay, now. So what is it? The order. What is it? The order. The order in which data is stored, that was doesn't matter. That was doesn't matter. So what it was saying? The order in which data is stored doesn't matter. See now we can order, you can see roll number, for example. Here 1, 2, 4, 3, like this it was there. So it's not a matter. It's not a matter to I have to store in order format like 1, 2, 3, 4, 5, 6, 7, 8. So the kind of order format I have to store. So that kind of need and necessity is not required. Okay. So your order is not a matter. So you can store your records or number like 1, 2, 3 or 3, 2, 1 or 4, 2, 1, 3. So any order you can store it, but that is not a matter. Okay, now, so these are the four rules when your table is satisfied. When your table is satisfied, these four rules, then we called as a your table is to be in a first normal form. Your table is to be in first normal form. Okay, now let you see, for example, one table you can see. Student table is there, guys. Careful observe. In student table, can you identify here? So as per whatever the four rules we discussed guys here. Okay, now, so in these four rules, all rules are satisfied or else any rule is not satisfied. Can you check? Which rule is not satisfied? Come on guys. Which rule is not satisfied? Which rule is not satisfied guys? Come on. The four rules observed and tell me. Yeah. So your subject column is having more than one value. That means the rule, which one is not satisfied here? First ruler, second ruler, third ruler, which one? Yeah. First rule is not satisfied, right? First rule is not satisfied. Because what is your first rule? Every column should contain atomic value. Every column should contain atomic value. But unfortunately, my subject column, multiple values are there: Java, Oracle, and C++. So this is not allowed. Okay, na? So second rule is satisfied. Third rule is satisfied. Fourth rule is satisfied. But which rule is not satisfied here? First rule. First rule, what it was telling? Each column should contain atomic value, is nothing but single value. But unfortunately, my subject column is having multiple values in one row: Java, Oracle, and another C++. Then what we want to do, sir, to avoid this problem means then you have to break these rules, that is, break these values. I want to break it. So how we can break it here? Observe. How we can break it here? Observe. So directly you can come out and see. So now I'm going to dividing like this here: 101 Sai Oracle, 101 Sai Java, 102 Jones Python, 103 Ln C language, and next 104, 103 Ln C++. So now tell me, now your student details table, all four rules are satisfied. So first rule is satisfied. Each column contains single and atomic value. So that was satisfied here. And there is no intermix data type. As per column data type, same data storing. Third one is every column name is a unique name. There is no duplicate names. And finally, your order, storage of order 101, 102, 103, whatever it is. So here also we can store any kind of. Okay, na? So now your table is satisfying here. Okay, satisfying here all four rules. But somebody thinking that, sir, okay, satisfied, but we have a duplicates now. 101 Sai, 101 Sai, Oracle, Java means yes. Though there is no duplicates in this table, guys. Why, sir? Why, sir? There is a no duplicate means here. What it mean, guys? Here, composite primary key. So composite primary key, when you apply it on combination of columns, what we discuss, the combination should not be repeated. Okay, different combination is allowed, but same combination is not repeated. So that's why, so your composite primary key, I'm applying on these columns, roll number, name, and subject. So what it was happened, different combination is accepted, but same combination is not accepted. That's why in the last session I said to you, before come to normalization concept, first you should know excellent knowledge of primary key, foreign key, composite primary key, composite unique constant. Okay, you should know the knowledge. Without a constant knowledge, when you come to this normalization classes, there is a lot of confusion is there. I already, before starting of my normalization concept only, I informed to you guys. I think you all of you remember. So before starting normalization only, I was given one hint for you. So everyone should go and recall your constants concept and come to classes. Without constants knowledge, don't attend normalization because it is a completely depends on your constants. Okay, so I hope that you people remember composite unique constant, composite primary key constants we discuss. When a constant is applied on a multiple combination of columns is called as a composite. And whenever you want to inserting the data, how the data will be verified means so the combination of columns data verified. So that was clear. I already clearly informed to you, I clearly explained to you in the constants. So that's why in this table, I expected so many people thinking a duplicate data is there, but it is absolutely wrong. There is no duplicate data because reason is my composite primary. So the combination is what now? 101 Sai Oracle. This is one combination. Second one, 101 Sai Java. This is another combination. This is Oracle combination. This is Java combination. Okay. So for example, here also I have an Oracle. Here also I have an Oracle. Then we called as a, this is a duplicated data. This is a duplicate data. Because 101 Sai Oracle, 101 Sai Oracle combination is same. Then this data is not allowed actually. When you try to insert it, it is not allowed because it is a duplicate. But here the point is, here what it was there, not Oracle, it was there what? Java. So this is a different combination. Point understanding now? It's a different combination, not a duplicate. Okay. So that because of reason, composite primary key. Suppose you guys are, yes. Suppose you are not applying composite primary key on these columns. Suppose I'm not applying here. I'm not applying, yes, you can say, yes, sir, we have a duplicate data in these two columns. You can say now 101 roll number, name columns are having duplicate data. Now we can say, because there is no composite primary key, then definitely it is a duplicate. But the point is what now? We have a composite primary key was there. So when composite primary key was there means compulsory duplicate combination of data is not repeated, different combination of data only accepted. So in such a manner, you can say in this table, there is no duplicates. Okay, now? Are you understanding my point now? Yes. So this is first normalization table. That means your table when it was having, okay, so each and every column is contained your single atomic value. As per column data type, same data values can be stored. There is no order. Order is not a mandatory, and every column is a unique name. Okay, na? So you can see every column name is unique or not. Roll number different name is different subject. So that's why there is no duplicate column. So that means all four rules are now your table is satisfied. So that means finally I can say this table is satisfied the four rules of your first normalization form. Okay, now right. This is first normalization form. How to go for this? Yeah, second one you can come on. Second normal form. So what is second normalization technique? Observe. So when a table, for a table to be in the second normal form, it must satisfy two conditions. It must satisfy two conditions. It must satisfy two conditions. Okay, now? So one is, first one, what it was? Compulsory, your table should satisfy all rules of first normal form. All rules of first normal form. Okay, now? All rules of first normal form. And second one is, your table should not contain partial dependency. Your table should not contain partial dependency. Okay, now? So partial dependency should not be there. So this is two conditions when it is satisfied, then you can say your table is in second normalization form. Okay, now? So already the first normal form, we just discussed the four rules, whatever it was there. The rules are, we already know. So the rules you have to check on your table, whether there are not there. Okay. Now, suppose it is there. Okay. The first condition will be satisfied. What is my second condition? There should be no partial dependence. Suppose in case your table is having partially dependency columns are there in your table, then immediately those partially dependency columns are avoided, remove from your table. Okay, now, so that is second condition is telling us. But before you want to know about the partially dependency, okay, first of all, we should know what is dependency. First, we should know what is a dependency. First, we should know what is a dependency. Okay, now, let us see. So your dependency means what? Observe. Careful, observe. Statement, observe carefully. In a table, observe, in a table, if non-key columns, non-key is nothing but non-primary key columns. Non-key columns, nothing but non-primary key columns. So in a table, if non-primary key columns are depends on key column means primary key column. Carefully, statement one or two times, read one or two times, read and understand the statement first of all. What we are telling, in a table, non-key columns means non-primary key columns, are depends on a key column. Key column means primary key column. So whenever the non-primary key columns are depends on a primary key column, then it is called as a fully dependency, otherwise functional dependency we call. We called as what now? Fully dependency, or else we called a functional dependency we called. Functional dependency we called. Okay now? Right. So this is okay, the definition of what is dependency. For example, let us see here, just a definition statement example of A comma B comma C comma D. There are total 4 columns are there. In these 4 columns, A column is a primary key column. A column is a primary key column. And B, C, D non-primary key columns. Okay, now A is a primary key column, B, C, D non-primary key columns. Then what happened? B comma C comma D, these non-primary key columns are depends on A column. Then it is called a fully dependency. Then it is called a fully dependency. Okay. For example, database example you can observe. I have one table, student details, guys. Careful observe. In student details or to student table, we have a student ID, student name, branch, address. In this table, student ID is a primary key column. So student ID is a primary key column, but name, branch, address is a non-primary key columns. Okay now? Right. Then tell me guys, with the help of this student ID column data, can I get all details of a student? Is it possible? If I know a student ID number, based on the student ID number, can I get the entire the details of a particular student? Is it possible? Come on guys, yes or no? Okay, right. In the same to same, for example, if I know employee ID number, based on that employee ID number, Can I know entire the details of employee? Yes, of course. So yes, of course. Okay, now right. So now this is what it is called. That means with the help of one primary key column, okay, I can get a remaining all details here. It means what now? The student name, student branch, student address, these all are depends on student ID. These all columns are depends on student ID. Point is understanding now? Depends on student ID. Okay. So that means what happened in this table, there is no partial dependency. In this table, there is no partial dependency columns. All are depending on student ID. Your name is depending on student ID. Branch is depending on student ID. Address also depending on student ID. So that means all three columns depends on student ID, and based on student ID, the remaining three columns of data also I can get it. That's why this table is having a fully dependency was there. But when your table is having fully dependency, then there is no need to do any modifications here. And this table successfully satisfied my second normalization form. This table successfully satisfied my second normalization form. Understanding now? Right. But, okay, sir, in this table, there is no partial dependency problem. Fine. But now, suppose if your table is having partial dependency, then how to overcome? Okay, now you can see. Now the definition is, what is partial dependency? What is partial dependency? Okay, now you can see. First definition observe, guys. First definition observe. In a table, if non-key column, that means non-primary key column, depends on the part of key columns, the part of key column, then it is called a partially dependency. Okay, now? Definition understanding the non-primary key column depends on part of primary key column, part of primary key column, then it is called as a partially dependency. Partial means half of the. Okay, for example, you can see statement example. A comma, B comma, C comma, D. These are four columns. Out of four columns, so A comma B, these are two primary key columns. That means A column, B column, these are primary key columns. That means composite primary key columns, combination. Okay, na? Combination. C comma D, non-primary key columns. Okay, na? So here what happened? Definition statement is what now? A and B is a key columns, but C and D are non-key columns. And D depends on B, but not A. Otherwise, D depends on A, but not B. In the same to same, C depends on B, but not A. Otherwise, C depends on B, but not A. C depends on A, but not B. So this non-primary key column is depending on any one column of primary key. Any one column of primary key. For example, suppose a child is there. A child is having mother and father. Suppose a child is depending on father and mother, then it is called a fully dependency. Point understanding now? A child is depending on father and mother, then it's called a fully dependency. Suppose sometimes what happened, a child can depending on anyone. If a child is depending on more father but not mother, then partial dependency. Suppose a child is depending on mother but not father, then it is called a partial dependence. So that means any one person dependable is there, any one person dependable is there, then that is a partially dependency we call. Suppose a child is depending on mother and father, then it is called a fully dependency. But if any one is there, then it is a partially dependency. For example, nowadays some childs are having mother but no father. Some childs are having father but not mother. So that is called a partially we called. But when a child is having both of them, then it is called a fully. So this is just a simple example to understanding purpose I was given. Okay. No? So here also same in database also partial dependency means what? No, non-primary key columns are depending on any one of primary key column in a table is called as a partial. Okay, I hope that the definition understand. Let me come out to your table. So example table you can see. So here came out. Here came out. Here I was applied primary key. Okay, here I was applied primary key in this table, score table. My table name is what now? Score table. My table name is what now? Score table. Okay, now right. In score table, there are 4 columns are there. In score table, there are 4 columns are there. One is student ID, subject ID, marks, and teacher. So student ID column, subject ID column, both are composite primary keys. So point understanding now? Both are composite primary keys. Carefully observe. Composite primary keys. Okay now? And marks, teacher is a non-primary key columns. Marks and teacher, non-primary key columns. Now I'm asking to you. Now I'm asking to you. Now one of non-primary key column, marks is there. Tell me guys here, marks is depending on student ID or subject ID or both of them. Just practically think and tell me. Marks is marks column depending on student ID or subject ID or both of them. Come on. What do you think, guys? Both are depending or any one? Both. See, marks column is depending on both student ID and subject ID. Because without student, marks we can't get. In the same to same, without subject, marks we can't get. So when we getting marks means student is required, subject also there. So student and subject, both combination, marks will be getting. Yes or no? So student is writing examination on subject. Student is writing examination on subject. After examination, how much he gain marks, that is called a marks. So that means what do you understand here? Marks column depends on student ID and subject ID, both the primary key columns. Then tell me, then marks is a fully dependency column or partially dependency column, guys? fully dependency, right? It is a fully dependency. Okay. So with fully dependency column, I don't have any problem. Okay, now I just keep it as it is. Come to teacher is there. Now tell me guys here, carefully tell me, practically think. Teacher is depending on student or subject? Teacher is depending on student or subject? Yes, teacher always depend on subject, not a student. Because reason I'm telling why means students are coming and going. Yes or no? For example, so I'm teaching Oracle to you guys. So after 10 to 15 days, okay, after 10 to 15 days, suppose your course is completed and you all of you left from me. Okay, because your course is completed, you are leaving. Yes or no? So when your batch is completed, you all people are left from me. Then what happened? Again, in this time, one more new batches come to me. Again, new students, new batch, again come to me. So again, those people also up to their syllabus, up to their course, they will be stay with me. And once they completed their course, they left for me. Okay, but your students are coming and going, but teacher always with the subject. See, I'm teaching Oracle for you guys, and in coming soon, some new batches are coming out. So those people purpose also I'm teaching same subject. So that is what happened. Subject is always with the faculty or teacher. But students not a permanent. Students are coming and going. But subject is always permanent to teacher. So that means what you understand, guys, here. Now this teacher column is depending on student ID or subject ID. Definitely subject ID. So that means now tell me teacher column is a partially dependency or fully dependency? Partially dependency. So that means in this table, we have a one partially dependency column. But whenever your table is having partially dependency column, then the table is not comes under second normalization form or second normalization technique. Okay, now then what we want to do, sir? Then what we want to do, sir, means simple. So which column is partially dependent column is there? Which column is partially dependency column is there? That partially dependency column I'm just removing from the score table and keeping into another table. Okay, removing from score and keeping into another table. Okay, now, so that is how it is means simply compact. Simply. So now this is one table, subject table. The subject table I created in this I was given subject ID, subject name, teacher. Okay, now so this is one table and my score table. Score table is having student ID, subject ID, marks. Now what happened? Your score table is satisfying second normalization form and your subject table is also satisfied second normalization form because in the subject table and in the score table there is no partially dependency columns. Okay, now in subject table there is no partially dependency columns. Now you can see teacher. Yes, teacher always subject ID, subject name. Yes or no? It is also fully dependency. And score table is also marks. Marks always depending on student ID, subject ID. It is also fully dependency. Then what happened in these two tables? There is no partially dependency column. So that means what you say? These two tables are satisfied my second normalization technique. Understanding now? Come on, guys. Okay, so this is second normalization technique, how this technique will be implemented on our tables data. Okay, and next one is third normal form, guys. But this third normal form and remaining two techniques, whatever it was there. Okay, now so that we will see in Monday session, guys. So I'm stopping today. Okay, so Monday the remaining whatever the techniques are there, that we will discuss on Monday. Okay, now so Monday, once it was completed, then I started PLSQL language. It may be Tuesday or Wednesday we started PLSQL, and I need 15 sessions we require PLSQL to complete. Okay, now right, yes. So thank you guys, and happy weekends, guys. Thank you.